talking about two things. We were talking about error approximation and what was the new rule we were dealing with yesterday? Simpson's rule. The Simpson's rule get us a pretty accurate approximation for a definite interval.
Yes.
It does. And does that happen with many intervals, or can we get a pretty good approximation with few intervals this time? Got a pretty good approximation with few intervals, didn't we?
Yes.
Okay. So, next question then would be this. What was I gonna say? Calculator. Were you guys okay using that new left and right hand sum calculator to help us get some values to make this work yesterday? Because remember, some of the problems that I'm gonna assign today, they're gonna ask you to do this for like 250 intervals. I don't think you're gonna wanna do 250 intervals, are you?
No.
Okay. So do you remember what that link was? It's the approximation calculator in the website, so make sure you check that, okay? Hey guys, I know that my numbers that I put up here for fifth hour for this one that we're about to talk about in example 2 looks probably just a little bit different. I think we went 5 places on ours, didn't we? So what do you guys have for this left error of 2?
0.14018.
Well, pretty close, right? Okay. Don't worry about the difference. I'm not going to make you change your numbers, but what we are going to talk about here, guys, is the error ratios again. So the question that I have is this. I'm not going to worry about the error of 250 here. So, right here, you can just cross this column out. We don't really need that. We could probably make a prediction on it if we needed to, but we'll in a little bit. So, guys, what we're considering in example 2 is the definite integral. What are my limits here, kids? 1 to what?
2.
Okay. We said, I think the actual integral for this yesterday, did we say it was about 0.6913? Or 0.69315? Is that what we wrote down yesterday?
Yep. Yes.
Okay. So we had said, if I get into decimals, I go definite integral, lower limit 1, upper limit 2, 1 over x dx. The actual kicked out. I mean, it's not really an actual. We're still kind of approximating, but it kicked out about 0.69315. And then we got into that left and right hand trapezoid midpoint calculator. We found all the errors. This would have been the error for how many intervals, kids? 2. Error for 10. Error for what?
50.
Okay. So going from error 2 to error 10 to error 50, what multiple are we moving up each by? It's 2 to 10 to 50. What am I always multiplying by? Okay. So I'm going to put a 5 up here. Okay. It's kind of like saying we're multiplying everything by 5 right here. All right. Now, down below here, what we want to look at doing is using this table right here to say, well, let's talk about the error ratios. Now, kids, we talked a little bit yesterday that said, well, the left and right hand errors, if I multiply the number of intervals by a certain number 5, then the error from 2 to error from 10 should be cut by about a factor of what? 5. Let's just see if that's true here. So I want to look at E2 divided by E10. So error 2 divided by error 10. So for this first one right here, we're going to go negative 0.1402 divided by negative 0.0256. And what I need on you guys, I need some volunteers. I need a volunteer to help me. Who wants to be my left-hand volunteer? Or who's just willing to punch numbers in a calculator for me? Maddie, are you willing to do that for me?
On your calculator online?
No, just a regular calculator.
I can do it.
What's this error 2 value? Negative 0.1402 divided by this error 10 value, negative 0.0256 for me.
5.47.
5.47. I'm going to write 5.47 right here. Okay, now, Maddie, can you do this for me? Can you do the negative 0.0256 divided by negative 0.0050? Very good, 5.12. Looks like to me, if I would keep going, if I would have gone from error 50 to error 250 right here, kids, which we didn't do, and that's okay. But these numbers or those ratios that we're getting, it looks like that 5.47 down to 5.12, probably getting closer and closer to what value? 5, okay? So here's the deal, kids, all right? If I wanted to know what the error of 250 was up here, even though we crossed this off, what was the error of 50 up here, kids?
-0.0050.
Okay, and under left and right hand rules, it says if you want the next, multiple of 5 going from error 50 to error 250, not saying it's exact, but if you would take this and divide by what value, which is really 5 to what power, first, this would probably give you an error of 250. If I took this and divided this by 5, this would be about negative 0.0010, okay? All right? So what I like to do with these, when I get into these tables like here, I like to go, okay, my errors are going up by a multiple from 2 to 10, so it's multiplying by 5, multiplying by 5, multiplying by 5. I like to come down here by the left and right, I just like to write, okay, every time I move up by a multiple of 5, my error is going to get cut by that value 5 to the first, okay? You guys remember what the rule was for trapezoid and midpoint yesterday? Not 5 to the first in this case, but 5 to the what? Anybody remember what Simpson's was? Fourth power. I like to write those down right away and say, okay, I think that's going to be what's going to happen here, all right? So I'm not really going to worry about error 50 divided by 250 because we didn't do 250. So I need some help with the right-hand value. Let's talk right-hand values up here, okay? I need someone to go 0.1098, error 2, divided by 0.0244, error 10, both for right-hand sums. So what is that 0.1098 divided by 0.0244?
4.5.
4.5. Okay, can you do the 0.0244 here divided by 0.0050? Either way, both are pretty close to what, kids? Okay. Okay, so again, that's that rule, all right? So if I wanted to come over here and get an error for 250, if I was predicting this right here, I would take this 0.0050, which is an error for 50 intervals on the right-hand sum. What would I divide this by to get a prediction for 250 intervals? What would that error prediction be? What would I divide this by to get a prediction over here? Divide by 5, so an answer for that might be about 0.0010. Okay. All right, let's do the same for the trapezoid and the midpoint. Guys, we should say that these values right here, to go from the error of 2 to error of 10, this should get divided by about what value? Well, we think it's 5 to the second, which is what value? 25. Let's just double check that. Are we close to 25? So this trapezoid rule right here, take the negative 0.0152 divided by this trapezoid of 10 for error. 24.1. Okay, and I've got these mixed up a little bit, but that's okay. I'll put 24.19 there. Kids, is that 24.19 pretty close to what we thought we should be dividing by?
Yes.
For errors? 5 squares, what value?
25.
Okay, is it exactly 25? No, but I can get away with this because are we doing exact values or are we approximating? We're approximating, okay? Do the next one. Negative 0.0062 divided by this negative 4 zeros 250 for me. Getting pretty close to what there, kids?
25.
I like it. So here's a question, kids. What was the error for 50 intervals? What was the error for 50 intervals up there for my trapezoid rule? I just circled it.
Negative 0.00000.
Okay, so that value up there, negative 0.0000250, if I wanted to know what the error might be for 5 times the intervals, going from 50 to 250, I could take that error that I circled and probably divide by what value to get to the next multiple. Divide it by 25. Somebody do that for me, kids. If I divide this by 25, I think that this would become negative 0.00. Oh, I don't know. You tell me.
Negative 0.000001.
5 zeros and a 1?
Yeah.
Okay. Let's see if the same thing happens for midpoint. We think, then going from like here to here, this error should get cut by about what value, or be divided by what value? Well, what's 5 squared again, kids?
25.
Is it gonna be exactly 25? Maybe, but we better hope it's close to what?
25.
Okay, go 0.0074 divided by 0.00031.
23.87.
Okay, so in the ballpark. Let's do the next one here. 0.00031 divided by 0.0000125. Something doesn't seem right there. It's very possible.
24.8.
It's very possible I typed something there. What'd you get there?
24.8.
24.8.
I did the one above it.
I like that a lot better. Okay. All right, so 24.8, is that getting us close to that value of 25 again?
Yes.
So kids, if I wanted to know an error for 250, I said we crossed it off. I didn't even put them on there for you. But if I was predicting an error for 250 intervals, I would take this value right here and divide by what? 25. Okay, somebody divide that out for me. If I divide by 25, what's a good estimate there?
Point 0.000005. 6 zeros in the front.
Okay, 0.60, 1, 2, 3, 4, 5, 6, and then what is it, 5 at the end? Okay, my question to you guys is this. The values that I have right here, do you understand the relationship of error ratios? It's like to go from one error to the next multiple, do we understand why I put 5 to the first out here? All those values are pretty darn close to 5 to the first, aren't they? Okay. For this one right here, do we understand why these values right here for midpoint and trapezoid, do you understand why I put 5 to the second out here? Well, all those values are pretty darn close to what? 25. Okay, Simpson's rule, a little different. Again, we talked about this yesterday and I said, well, it's actually going to be a change by 5 to the 4th. So we're going to be dividing or cutting by, this case, 5 to the 4th. I just want to make sure you understand this. First of all, what is 5 to the 4th?
600.
Close, 625, okay? Now, thing I'm going to show you about this, when we start talking about values, first of all, guys, are we talking about a lot of error here or minimal error right here?
Minimal.
Okay, so understand something right here. When you take something that's really, really small and divide it by something pretty big, it's still going to be really, really what? Small. Some of these values are going to sway away from 625 a little bit because of where we round or where we cut the decimal off at. When we're talking about very, very small values, to be more exact, we would want our decimals to get longer and longer and longer. I can only go so far in that box right there, okay? But you would eventually start closing in on 625. So let's just check to see kind of where we're at. I need to do this Simpson error 2 ratio compared to error 10 under Simpson. So anybody willing to type that mess in?
550.45.
550 point. You're already ahead of me. I love it, Gibby. Okay, so like you're driving a Chevy compared to everybody else.
Uh-huh.
Walked right into that one. Did you happen to have the next one, bud?
Yeah, 646.67.
Okay. 0.47?
67.
67? Perfect. Okay, now question here. Are those values fairly close to 625?
No.
You know, they're kind of close, but they're a little off, right?
Right.
Guess what this is going to go back to? The difference in this is going to go back to where I cut my decimals off at, okay? So what I'm getting at is this. Yeah, these values get a little bit further away, but they're still fairly close to 5 to the 4th, which is 625. So if I come up, oh, good God, Ford, good Lord. Weird. Okay, my point is this. If I wanted to know an error prediction for 250 intervals within Simpson's rule, what would be a good value to divide by? Well, what did you guys say 5 to the 4th value was? So to divide by 625. Okay, so somebody take that mess, divide by 625. There are going to be lots of zeros in this.
I have like an E in my answer.
So what's it say?
Negative 4.8
Okay.
4.8 times 10 to the negative 13.
So that's like negative 4.8 times 10 to the negative 13. So this would be like a decimal point with 12 zeros. Negative 0.0, 1, 2, 3, 4, 5, 6, 8, 9, 10, and then 4, 8. Now kids, let me ask a question. Is that really any error at all? I mean, if I paid you that amount of money, would that be anything really?
No.
You know how long that would take to make a penny? How many of those it would take to give you a penny? You get a lot. Okay? So that error is pretty small right there, all right? But do you understand why I'm dividing by 625 there? Well, my intervals are going up by multiples of, well, I don't want to say multiples of 5, we're going by a factor of 5, because 2 times 5 would make 10. Does that make sense to everybody? Okay. So that's how that kind of works right there. So what I want to do is kind of talk about these rules about errors with intervals. The question is going to be, how do you work these rules, okay? I'll just give you an example right here. When we're talking left and right here, kids, if you want to find new errors, all right? So let's just take this as an example. You would take your previous error and divide it by whatever your factor is to what power have I been using with left and right hand sums? First, second, or fourth? First. Okay. So let's just say that we're going from n equals, I don't know, 3 intervals to start to n equals 12 intervals right there. Okay. Does that make sense to you? All right, so what I would say is this. My error for 12 intervals would equal, what was my previous number of intervals, kids? We went from what to what?
3.
Okay, so to get to 12, the previous one was how many intervals?
3.
So there had to be an error for 3 intervals before there could be an error for 12 intervals, okay? My error for 12 intervals is approximately my error for 3 intervals divided by what value? Anybody take a guess for me in this example? We went from 3 intervals up to 12 intervals, so what factor did we move up by?
4.
Yep, 3 to 12, it would be 4 times the amount, right?
Yeah.
So if I wanted to predict the error for 12 intervals, I would have to know the error for 3 intervals, but I would take that error and divide it by what? 4. 4 to the first, right? Okay. For midpoint and trapezoid rule, you're going to take your previous error and divide it by the factor to what power? For midpoint and trapezoid rules. So in this case right here, if I want the error of 12, the error I knew prior to 12 was the error of what, kids? Well, error of 3. And then I would divide that by the factor to what power?
Lisa.
So what are we going to divide by there to get our approximation of 12 intervals?
4.
4 to what power though?
The second.
So this should be what down here?
16.
There you go. And then same thing for Simpson. Simpson is going to be the previous errors. Oops. All of my factor to what power for Simpson?
3.
Not 3, but 4th power. Okay, so in this case, if I was going from, if I started and I knew 3 intervals and I knew the error for 3 intervals under Simpson's rule, I could then say the error of 12 intervals is approximately, and I shouldn't put equals here, I should put approximately, and that's okay. The error I know from 3 intervals divided by, maybe you don't know the number yet, but what to the what?
4 to 4.
Anybody know 4 to the 4th power?
No.
Turns out to be 256 is what you would divide by. Okay. So, let's take that concept. Hang on a second, kids. Something's bothering me here. Sorry about that. I sometimes the board gets a little dirty with markers. Bugs me. Does that bug anybody else?
Yes.
Sorry. Say something.
No, it's okay.
My eyes probably aren't as good as yours. Well, who am I kidding? I know they're not as good as yours. All right, friends. So let's take this idea and transfer this over to see if we can't figure some things out, okay? Everybody have what they need for this page first?
Yes.
Okay, let's move along here. Last page, friends. So I really like this last example. I think that if you understand this example, then you've mastered everything, okay? Example 3 says completing the table. So in example 3, this says the following. Some approximations for a certain definite integral are given in the following table. It says use the fact that the exact integral is what, kids?
0.6931.
We've talked about that value, haven't we? Just going to highlight that. We know that there's some integral out there, lower limit a, upper limit b, of some function f of x dx, where the actual value is 0.69315. That's the actual value. Now, they give you an approximation for the left hand, the right hand, trapezoid rule, midpoint rule, and Simpson's rule for how many intervals, kids? We have approximations for how many intervals? 2. Okay? Here's the deal. If I know the actual value right here, and I know the approximate values for each of our approximation types, could we find all those errors? Let's do that. Okay? To find this first error right here, you would take 0.69315 and subtract what value?
0.83.
Help me out with that. What is that number?
Negative 0.8333. What the heck?
So, okay, so we would go 0.69315 minus 0.83333, right?
Negative 0.14015.
Negative 0.14015, you say?
Yeah.
That seems. Should that be a 1/8 maybe?
Yes.
Double check that here though. Wanna go, so we're going 0.69315, right? Minus 0.8343 is right. I'm getting one, everything's the same. The 5 I'm getting is an 8 though.
Oh, yeah,
Okay with that?
yes,
Okay. So are we cool with that value, kids?
yeah. I think
Okay,
I said it right.
let's do the next one, the 0.69315 minus 0.58333. And these numbers should look familiar, they're the same numbers that we've talked about. I get 0.10982.
Yeah,
Okay. Trapezoid rule. So the approximation is 0.70833. So to get the error for the trapezoid rule, this would be the 0.69315 divided by, or I'm sorry, not divided by, minus 0.70833. What are you guys getting for that one? I'll talk at once. I get this right here.
that's what I have.
Okay. Midpoint, I'll go 0.69315 minus 0.68571. I've got 0.00744.
Yep.
Guess this last error, 0.69 minus 0.69325. Is there some error in the Simpson's rule? Yeah. 0.69315 minus 0.69325. I get negative 0.0001. Do you guys get that? Okay, now here's the deal. I want to be able to make a prediction what the error will be from not 2 intervals, but what? 20 intervals. Okay, this is the part where I think that if you can help me with this, then you kind of understand everything that we're doing in this section. So, talk to me, my friends. What was the previous number of intervals for our error? 2. We want error for how many intervals? 20. So up here in the box up top here, I'm just going to write down our factor is what, kids? We're going from n equal 2 to n equal 20. 10. So I'm just going to put a 10 here. I just like to put the 10 there because to get from 2 to 20, you got it times by what? 10. Okay, so my error approximations for left are going to get cut by, or divided by 10 to the first. Trapezoid midpoint are going to get cut by 10 to the what? Uh-oh. I thought they were talking about me. They were talking about my laptop. I thought I was going to fall asleep there for a second there, Grant.
I could also.
Let's back.
I'm pretty good at doing that. It's back!
Hey, your battery's low.
Hey,
Just like the truck.
Ease down. Good God. Gibby, what have I done to deserve this? Oh boy. Oh, I bet I know what's wrong.
did.
Plug in your PC.
Well, no problem. Hang on a second. I can do this. Okay, I'll fill in some values up here, but guys, we talked about this right here. It says we want to figure out what we're gonna be dividing by. So in this next one right here would have been 10 to the what power? For trapezoid midpoint rule. Divide by what? Good gravy.
Your keyword is 2, 3, 1, 8.
2318.
Can't see that.
What about that eyes?
Divide.
Doctor, or the doctor told me only trust that the DOT told me I desperately need them.
What was your test that you had to do?
Yeah, I accidentally read off letters and they're supposed to be reading off numbers.
I did it. I read the wrong part. Did I make you do it?
All right, let's try this again.
First thing I saw, I was gone.
Did that number change up there, kids?
Do it then.
No, I didn't do it.
And then she just goes, it's the numbers.
You gotta be more specific.
The first time she had told me to take my hat off, so I was just looking at it. Can't see anything. I said, can't see anything.
Okay, my frustration level has gone up by a factor of 3.14. But you know what? I don't like to give up easily. So let's try this.
You joined a Dodge, you wouldn't have these problems. Did you know that?
Well, will you looky there? All right, so let's finish this up here. So right here, kids, this is the part I'm at right here. What's my error for two intervals, kids? Right up here, what's my error for two intervals? Everybody right up there.
1, 4, 0.
What am I going to divide that by to get an error approximation for 20 intervals? Okay, so can't I just move the decimal 1 to the left if I'm dividing by 10? So 0.014, here. Okay. Same thing down here with the right. What was the error for two intervals? This should have been a positive, right? Positive 0.10982. Okay, move the decimal how many places to the left? This would be 0.0, gosh darn it, 0.019. I'm sorry, 0982. Okay, now kids, for my errors on trapezoid and midpoint to go from an error of 2 intervals to an error of 20 intervals, instead of dividing by 10, we're going to divide by, so really how many places am I moving a decimal there? So this would be negative 0.0001518. Okay, what's the next one going to be? Very good. Okay. And this last one for Simpson's rule, we're not going to divide by 10 to the second, but we're going to divide by what? That's like moving the decimal how many places to the left? So instead of having 3 zeros out front, we will have
7.
there it is. Okay. You guys understand how I'm getting these error approximations? Using the rules that apply to left and right, trap and mid, and Simpson rule. Okay. Guys, your assignment, you might want to write this down, is going to start on page 354. Okay, page 354. I'm asking you to do, all right, first of all, you're going to do number 8. And then the other problems will be 1 through 19 odd. So I want you to do 1 through 19 odd and then problem number 8. And that's on page 354.